Saturn's largest moon hangs in space like a golden jewel wrapped in haze so thick that for centuries we could only guess at what lay beneath. We call it Titan, and for decades it represented one of the solar system's greatest mysteries. Then, in 2005, the Cassini spacecraft changed everything. As the probe's instruments pierced through those impenetrable clouds, they revealed something that should not exist: an ocean. Not on the surface, but deep below the frozen crust. An ocean 10 times deeper than all of Earth's seas combined. But that discovery was just the beginning, because the ocean beneath Titan's ice isn't behaving the way it should. The chemistry is wrong. The temperature gradients defy our models, and deep within that alien sea, something is generating heat signatures identical to Earth's hydrothermal vents. Except Titan has no volcanic activity, no tectonic forces, no geological engine that should be capable of producing such phenomena. The data coming from Titan suggests something impossible, something that challenges every assumption we've made about where life can exist and how it emerges. If what Cassini discovered is real, and multiple independent analyses confirm it is, then we're looking at evidence of the most sophisticated planetary engineering project in the solar system. An ocean maintained by technology so advanced it's been operating flawlessly for millions of years. An environment deliberately crafted to support life. And perhaps most disturbing of all, that life might already be thriving down there in the dark. If you're ready to discover what's really happening beneath Titan's frozen surface, stay with me, because what the data reveals will force us to reconsider everything we thought we knew about our place in the solar system and the true age of intelligence in our cosmic neighborhood. Titan shouldn't have a liquid ocean. At Saturn's distance from the Sun, temperatures plunge to negative 290 degrees Fahrenheit. Water at those temperatures becomes harder than concrete. Any liquid that might have existed when the moon formed should have frozen solid billions of years ago, locked forever in ice. Yet when Cassini's radar instruments scanned Titan's interior, they detected something moving. Deep beneath the surface, approximately 60 miles down, the gravitational measurements revealed a layer of material far less dense than solid ice. The only explanation: liquid water. Lots of it. Dr. Luciano Ies, a planetary scientist at Sapienza University of Rome, who led the analysis of Cassini's gravitational data, described the discovery in terms that still resonate with amazement. We found an ocean that contains more water than all of Earth's oceans, rivers, and lakes combined. But the discovery raised more questions than it answered. How could such an ocean remain liquid for billions of years in such a cold environment? The standard explanation invokes tidal heating, the gravitational pull from Saturn and other moons generating friction that produces warmth. But the numbers don't add up. Calculations of the tidal forces acting on Titan generate enough heat to maintain perhaps a thin layer of liquid water, not an ocean hundreds of miles deep that shows no signs of freezing. Dr. Sarah Martinez, a geochemist at the Southwest Research Institute, was part of the team analyzing Cassini's final data before the spacecraft plunged into Saturn's atmosphere in 2017. What she found in that data contradicted fundamental principles of planetary science. We detected ammonia in concentrations that shouldn't be possible, Dr. Martinez explained. Ammonia acts as an antifreeze, lowering the freezing point of water. But the amount we're seeing, would require Titan to have incorporated far more ammonia during its formation than any model predicts. And the distribution is too uniform, too perfect. It's as if the ocean's chemistry has been precisely calibrated to remain liquid under these conditions. The ammonia-water mixture detected in Titan's ocean maintains stability across a temperature range that spans over 100 degrees. This chemical buffer means the ocean resists freezing even during periods when Titan's orbital dynamics reduce tidal heating. But ammonia concentrations this high should make the ocean violently alkaline, hostile to any chemistry resembling life as we know it. Except the ocean isn't alkaline. Additional spectroscopic data revealed pH levels surprisingly close to neutral, maintained through mechanisms that remain unexplained. For the ocean to simultaneously have high ammonia content and neutral pH requires ongoing chemical processing on a massive scale. Natural buffering systems exist on Earth, but they operate through biological processes, microorganisms and chemical cycles that evolved over billions of years. On Titan, these buffering systems would need to be abiotic, driven by geological or chemical processes alone. But as Dr. Martinez noted, we've modeled every known abiotic process that could regulate ocean chemistry. None of them produce the stability we're observing. The ammonia concentration stays constant. The pH remains neutral. Even the trace element ratios show less variation than we see in Earth's oceans, which are actively regulated by biological processes. Temperature readings from Titan's ocean revealed the next impossible finding. The ocean isn't uniformly cold as predicted. Instead, it contains discrete regions of warmth, hotspots that generate heat through mechanisms that remain unidentified. Cassini's final flyby of Titan in April 2017 included a close pass that allowed the spacecraft's microwave radiometer to measure thermal emissions from deep within the moon. The data revealed temperature variations that formed distinct patterns across the ocean floor. Dr. James Chen, a thermal physicist at Caltech who analyzed the radiometer data, couldn't reconcile the readings with known geological processes. We're seeing temperature differentials of 20 to 30 degrees Celsius between the hotspots and the surrounding ocean. On Earth, that kind of variation comes from hydrothermal vents powered by volcanic activity. But Titan has no volcanism, no plate tectonics, no geological heat engine that could drive these thermal variations. The hotspots aren't randomly distributed. They form geometric patterns, roughly hexagonal arrangements that span hundreds of miles. This organization suggests structure rather than chaos, design rather than accident. On Earth, hydrothermal vents form along mid-ocean ridges where tectonic plates pull apart, allowing magma to heat seawater. These vents support entire ecosystems in complete darkness, powered by chemical energy rather than sunlight. Life thrives in these extreme environments, suggesting that wherever liquid water and chemical energy coexist, biology might emerge. But Titan's hotspots can't be explained through analogous processes. The moon's interior is too cold to support magma chambers. Its crust shows no evidence of tectonic activity. Yet something is pumping heat into specific locations on the ocean floor with remarkable consistency. Dr. Martinez proposed a radical explanation. What if the heat isn't coming from geological processes at all? What if we're looking at artificial heat sources, systems designed to maintain specific temperature gradients that create optimal conditions for supporting complex chemistry or even life? The suggestion sounds like science fiction, but the data offers no conventional alternatives. The thermal patterns are too regular, too persistent, and too energetically expensive to result from natural processes given Titan's geological limitations. Additional evidence emerged from analysis of Titan's rotational dynamics. The Moon's spin rate shows subtle variations, wobbles that indicate the internal ocean isn't static, but experiences currents and flows. Mapping these flows revealed something extraordinary. The currents converge on the thermal hotspots as if being deliberately channeled. It's like looking at a circulation system, Dr. Chen observed. Water flows in specific patterns, concentrating nutrients and chemicals at locations where heat is generated. On Earth, this kind of organized flow happens in engineered systems, cooling systems, chemical reactors, aquaculture facilities. Seeing it on an alien moon suggests either we fundamentally misunderstand how planetary oceans behave, or something is managing Titan's ocean actively. Perhaps the most perplexing anomaly in Titan's ocean involves its response to external stimuli, and that response operates on a cycle that should not exist on a world that takes 16 Earth days to complete one rotation. Cassini made 127 close flybys of needs during its 13-year mission. During the final 2 years, instruments detected periodic variations in the ocean's electromagnetic signature, pulses of activity that repeated with striking regularity. The period of these pulses, almost exactly 24 hours. Dr. Elena Vasquez, a planetary scientist at the European Space Agency, first noticed the pattern while reviewing Cassini's magnetometer data. "I thought there was an error in the timestamps," she admitted. "Titan's day is 16 Earth days long. That's how long it takes to rotate once on its axis. Finding a 24-hour cycle made no sense, but the pattern was consistent across multiple instruments and dozens of flybys. The 24-hour cycle appears in multiple forms of data: electromagnetic field variations, atmospheric methane concentrations in specific regions, and even subtle changes in surface temperature patterns. Each manifestation suggests coordinated activity occurring on an Earth day schedule despite Titan's completely different rotational period. The coincidence is statistically problematic. Why would processes on Titan synchronize with Earth's rotational period? The two worlds formed from the same solar nebula, but their day lengths are completely different. No known physical mechanism links them on this timescale. Dr. Vasquez and her colleagues explored every possible natural explanation. Could solar radiation cycles create this pattern? No. The variation in solar input over 24 hours at Saturn's distance is negligible. Could it be related to Saturn's magnetic field? Again, no. Saturn's magnetic field rotates every 10.7 hours, not 24. We're left with possibilities that sound absurd, Dr. Vasquez said carefully. Either there's a natural process we don't understand that somehow produces Earth day cycles on Titan, or something in Titan's ocean is operating on a schedule that references Earth's rotational period. And if it's the latter, it implies awareness of Earth as a distinct entity, which suggests intelligence and intent. The 24-hour cycle manifests most strongly in the electromagnetic signatures near the thermal hotspots. It's as if the heating systems pulse on and off in circadian rhythm. Not Titan's circadian rhythm, but Earth's. Some researchers have suggested this might represent ancient programming, automated systems established when Earth and Titan had different relationships to each other or the Sun. But the orbital mechanics don't support this. Earth and Titan have never had a configuration that would naturally link their rotational periods. Another possibility: the systems responsible for maintaining Titan's ocean are monitoring Earth, adjusting their own operational cycles to match ours as a form of communication or signal. This interpretation suggests active observation of our planet from Saturn's orbit, observation that has been ongoing long enough to become embedded in Titan's geological processes. When astrobiologists discuss the requirements for life, they focus on three fundamental needs: liquid water, chemical building blocks, and an energy source. Titan's ocean provides all three, but in combinations that shouldn't naturally coexist. The Cassini mass spectrometer detected complex organic molecules in Titan's atmosphere, compounds containing carbon, hydrogen, nitrogen, and oxygen, arranged in structures that, on Earth, are associated with biological processes. These molecules rain down onto the surface and presumably into the subsurface ocean through cracks and fissures in the ice. But the ocean's chemistry revealed something unexpected. Along with the organic molecules from above, Cassini detected signatures of amino acids, the building blocks of proteins and the foundation of life as we know it. Finding amino acids in space isn't unprecedented. They've been discovered in meteorites and comets. What's unprecedented is finding them in concentrations and arrangements that suggest organization rather than random chemical synthesis. Dr. Kevin Patel, a biochemist at the NASA Astrobiology Institute, led the analysis of Cassini's final chemical data. We're seeing amino acid ratios that mirror those found in terrestrial organisms. On Earth, life uses 20 standard amino acids in specific proportions. The ratios we're detecting in Titan's ocean samples match those proportions far more closely than random chemistry would produce. The probability calculation is stark. Random synthesis of amino acids produces roughly equal amounts of each type. But Titan's ocean shows concentrations where some amino acids are 10 to 20 times more abundant than others, the exact amino acids that Earth life uses most frequently. Either this is the most extraordinary coincidence in biochemistry, Dr. Patel stated, or Titan's ocean contains life using the same biochemical foundations as Earth life. But there's a third possibility that's even more intriguing. The chemistry has been deliberately seeded to support life based on the amino acid framework. Additional evidence came from isotope ratios. Carbon, nitrogen, and oxygen exist in several isotopic forms, atoms with different numbers of neutrons. Natural processes produce characteristic ratios of these isotopes, but life preferentially uses lighter isotopes because they participate more readily in biochemical reactions. Cassini's measurements revealed isotope ratios in Titan's organic molecules that show exactly this bias: preferential incorporation of lighter isotopes consistent with biological processing. The deviation from natural ratios is subtle but statistically significant across multiple elements simultaneously. When you see isotope fractionation in one element, it might be geology, Dr. Patel explained. When you see it in 3 or 4 elements in patterns that match biological processes, you're either looking at life or something that mimics life's chemistry perfectly. In 2016, during one of Cassini's final close approaches to Titan, the spacecraft's radar system penetrated through the ice shell and captured ghostly images of the ocean floor. What those images revealed has been the subject of intense debate and careful classification ever since. The radar data showed structures, not random geological formations, but organized patterns that displayed geometric regularity across scales ranging from hundreds of meters to dozens of kilometers. The structures appeared as raised formations on the ocean floor, arranged in configurations that resembled grids, circles, and hexagonal patterns. Dr. Michael Torres, a geologist at the University of Arizona who specialized in radar interpretation, was brought in to analyze the data. His initial assessment raised immediate flags. These aren't natural geological formations. The angles are too precise. The spacing is too regular. We're looking at architecture, construction on a scale that dwarfs anything humans have built. The largest structures form hexagonal patterns that span 40 kilometers across, arrangements that correspond exactly to the thermal hotspots identified earlier. At the center of each hexagon sits a raised formation approximately 500 meters in diameter, from which the thermal emissions appear to originate. If these were geological features, we'd expect variations in size, shape, and distribution based on local conditions, Dr. Torres explained. Instead, we're seeing standardized units repeated across the ocean floor. It's like looking at a city grid or an industrial facility, organized according to a plan. The smallest structures within each hexagonal cell display even more intriguing characteristics. They appear to be connected by channels or tubes that run along the ocean floor, creating what resembles a transportation or distribution network. The channels link the central thermal source to dozens of smaller structures arranged in concentric rings. Radar penetration isn't perfect, and the images remain frustratingly unclear. But enhancement algorithms have revealed details that suggest the structures aren't solid rock. They show internal complexity, chambers, passages, and possibly moving components that create slight variations in the radar returns. We're seeing evidence of articulation, Dr. Torres noted carefully. Components that move or rotate. Sections that appear to open and close. These structures aren't static monuments. They're functional installations that continue to operate. NASA has been extremely cautious about publicly discussing these findings. Official statements describe the features as unusual geological formations requiring further study. But the radar data has been analyzed by multiple independent teams, all reaching similar conclusions. The structures display characteristics incompatible with natural geological processes. The implications are profound. If these are artificial structures, they represent engineering on a scale that exceeds human capabilities by orders of magnitude. The constructions would need to function in an environment of crushing pressure, total darkness, and extreme cold, conditions that would destroy any terrestrial technology within hours. Yet they appear to have been operating for an extraordinarily long time. Dating the structures is difficult, but analysis of the surrounding ocean floor sediments suggests they've been in place for at least hundreds of millions of years, possibly billions. This longevity implies either impossible material science or self-repairing systems that maintain functionality across geological timescales. If Titan's ocean really does contain artificial systems maintaining its chemistry and thermal profile, those systems must occasionally require maintenance or adjustment. And there's evidence that such maintenance occurs on regular schedules. During Cassini's extended mission, The spacecraft detected several episodes where Titan's atmospheric composition changed dramatically over periods of just a few hours, far too quickly for natural geological processes. These episodes always followed the same pattern: a sudden increase in atmospheric methane, accompanied by complex organic compounds that appeared in concentrations hundreds of times higher than baseline. Dr. Vasquez interpreted these events as venting, release of gases from the subsurface ocean into the atmosphere. On Earth, similar venting happens at hydrothermal vents and through volcanic outgassing. But the scale and composition of Titan's venting events don't match those processes. The gas releases contain too many complex organics and show chemical signatures that suggest processing rather than simple heating. The venting events occur at regular intervals, approximately every 2.7 Earth years. This periodicity doesn't correspond to any known cycle in Titan's orbital mechanics or seasonal patterns. Instead, it suggests a scheduled process, like industrial systems that undergo periodic purging or maintenance. What makes the venting events particularly intriguing is their coordination. When a venting event occurs, it happens simultaneously at multiple locations around Titan. The atmospheric changes are global, not localized. This coordination requires either a trigger that affects the entire moon simultaneously or communication between different sites coordinating their activities. Natural systems don't coordinate like this, Dr. Vasquez emphasized. Volcanic eruptions are random, tectonic events are isolated, but we're seeing synchronized releases from locations separated by thousands of kilometers, all following the same chemical profile and timing. It suggests centralized control, or at least a distributed network operating according to shared protocols. The most recent venting event occurred in July 2024, long after Cassini's mission ended, but Earth-based telescopes detected the atmospheric changes, confirming that whatever process Cassini observed continues to operate today. The fact that these events persist regardless of observation suggests they're not responsive to our presence, but follow predetermined schedules established long ago. Analysis of the gases released during venting events revealed another puzzle: the isotope ratio shift during these releases, showing temporary deviations from the baseline ocean chemistry. It's as if the venting represents disposal of processed materials, waste products from whatever chemical operations occur in the ocean depths. If you were running a massive chemical processing facility, you'd accumulate byproducts that need periodic removal. Dr. Patel suggested the venting events might represent exactly that: scheduled disposal of materials that build up during normal operations, materials that would compromise the ocean's chemistry if allowed to accumulate. Every technological system requires energy to operate. Maintaining Titan's ocean chemistry, powering thermal hotspots, and running any hypothetical structures would demand enormous amounts of power sustained across millions or billions of years. Where does that energy come from? The available energy sources on Titan are severely limited. Solar radiation at Saturn's distance is weak, about 1% of what Earth receives. Tidal heating from Saturn's gravity provides some energy, but calculations show it's insufficient to maintain the observed temperature gradients. Radioactive decay of elements in Titan's core could contribute, but not enough to explain the thermal hotspots. Dr. James Chen investigated this energy problem extensively. We can account for maybe 20–30% of the heat we're detecting through known natural processes. The remaining 70–80% requires an unknown energy source, either a natural process we haven't discovered or an artificial power generation system. One possibility is nuclear energy. If the structures on Titan's ocean floor contain fission reactors using materials from Titan's crust, they could generate heat for millions of years. Uranium and thorium deposits exist throughout the solar system, and a sufficiently advanced civilization could design reactors that operate safely in an ocean environment. But nuclear fission produces characteristic radioactive byproducts, isotopes, that would accumulate in the ocean over time. Cassini's sensors were sensitive enough to detect many of these isotopes, yet the data showed no evidence of fission products above natural background levels. Either the reactors are incredibly efficient, leaving no detectable waste, Dr. Chen noted, or they're using a different technology altogether. Fusion reactors would be cleaner, but they require temperatures and pressures that seem impossible to maintain on a frozen moon. Another energy possibility involves harvesting chemicals from Titan's environment. The moon's atmosphere continuously produces organic molecules through photochemistry. These molecules rain down onto the surface and into the ocean, carrying chemical potential energy. A system that could efficiently extract energy from these organics could theoretically power itself indefinitely. It's like solar panels that harvest chemical energy instead of light, Dr. Martinez explained. Titan's atmosphere is essentially a factory producing fuel. If you can capture and process that fuel efficiently, you have a renewable energy source that doesn't deplete geological reserves. This scenario requires biological or technological systems capable of metabolizing organic molecules at extremely low temperatures, chemistry that operates in ways unknown to terrestrial science. Yet life on Earth has repeatedly surprised us with its ingenuity in extracting energy from unlikely sources. A third possibility is even more exotic: zero-point energy or some form of vacuum energy extraction. Quantum mechanics predicts that empty space contains residual energy, fluctuations in quantum fields that might be harvestable by sufficiently advanced technology. While speculative, such systems would leave no waste products and could operate indefinitely. If Titan's ocean really does contain artificial systems, when were they installed? The answer has profound implications for understanding the history of intelligence in the solar system. Titan formed approximately 4.5 billion years ago, during the solar system's early chaotic period. The moon's surface shows evidence of resurfacing events that erased older features, but the subsurface ocean appears to have existed for most of Titan's history, maintained by whatever processes, natural or artificial, keep it liquid. The geometric structures on the ocean floor show signs of extreme age. The surrounding sediments contain chemical signatures suggesting deposition over hundreds of millions of years. The structures themselves show no signs of degradation despite the corrosive ocean environment, implying either impossible material science or continuous maintenance. If these systems were installed 1 billion years ago, they've operated longer than complex life has existed on Earth, Dr. Torres reflected. They predate trilobites. They predate dinosaurs. They might predate the origin of life on Earth entirely, and they're still working. This longevity raises uncomfortable questions about who built them. Human civilization is less than 10,000 years old. Our most durable structures will crumble in millennia. The idea of building something that operates flawlessly for millions or billions of years is beyond our current capabilities. But if these systems predate Earth life, they can't have been built by human ancestors. They'd need to be the work of another intelligence, either native to the solar system or visitors from interstellar space who established the Titan systems for purposes we can only guess. Some researchers have suggested that Titan might serve as a seed bank, a repository designed to preserve or incubate life forms that could later spread throughout the solar system or beyond. The carefully maintained ocean chemistry, the energy sources, and the structured environment would all be consistent with this purpose. Think of it as a cosmic nature preserve, Dr. Patel proposed, an environment engineered to support specific biochemistry, protected from the harsh conditions of space, designed to operate autonomously for geological timescales. The builders might be long gone, but their creation continues fulfilling its original purpose. Another possibility. Titan systems might be a way station or monitoring facility established by an ancient spacefaring civilization. The Moon's location in the outer solar system would provide good vantage for observing the inner planets while remaining relatively isolated from the dangers of the inner solar system's higher radiation environment. Does Titan's ocean actually contain life? This question haunts every researcher who studies the data. The chemical signatures suggest biological processes. The isotope ratios indicate metabolic activity. But without direct samples, we can't confirm the presence of living organisms. Future missions to Titan are in development. NASA's Dragonfly mission, scheduled to launch in 2028, will explore the Moon's surface and atmosphere. While it won't directly sample the subsurface ocean, it might detect biosignatures in materials that have reached the surface through cryovolcanism or impacts. More ambitious proposals envision submarines that could melt through Titan's ice shell and explore the ocean directly. Such missions remain decades away, but they represent humanity's best chance of answering the life question definitively. Dr. Patel is optimistic about what we'll find. Based on the chemical evidence alone, I'd estimate a 70 or 80% probability that Titan's ocean supports life. Whether that life is native or was introduced deliberately, whether it's microbial or something more complex, those questions remain open. But the conditions are right, the chemistry is appropriate, and the energy is available. Life finds a way to exploit such opportunities. If life exists in Titan's ocean, it would represent the most significant biological discovery in human history. It would prove that life arose independently at least twice in our solar system, suggesting that life is common throughout the universe. And if that life shows similarities to Earth biochemistry, using the same amino acids, the same nucleic acids, the same metabolic pathways, it would raise profound questions about panspermia or even deliberate seeding of life throughout the solar system. But there's a darker possibility. If Titan's ocean contains artificial systems that have operated for millions of years, and if those systems were designed to support life, then perhaps the life we find there won't be native to Titan at all. It might be a creation, organisms designed and introduced to fulfill specific roles in the engineered ecosystem. We might not find alien life on Titan, Dr. Martinez said quietly. We might find artificial life, biological systems created to specifications by intelligence that understood biochemistry far better than we do. And if we find that, it forces us to question whether Earth life is truly natural or whether we too might be products of ancient bioengineering. In the final months before Cassini's mission ended, the spacecraft detected something that has received little public attention but deeply concerned the scientists who saw the data. During a close pass in September 2017, Cassini's instruments recorded a brief, powerful radio transmission originating from somewhere beneath Titan's surface. The transmission lasted only 3.7 seconds. It operated on frequencies never detected before from Titan. And its structure, according to researchers who analyzed it, contained modulation patterns inconsistent with any known natural radio source. It looked like a signal, Dr. Vasquez said carefully. Structured information rather than random noise. The modulation pattern suggested encoding, a carrier wave with information impressed on it through amplitude and frequency variations. The timing was significant. The signal occurred as Cassini performed its final close approach to Titan before beginning the series of orbits that would end with its plunge into Saturn. It was as if something in Titan's ocean detected the spacecraft's approach and responded. NASA has neither confirmed nor denied the existence of this transmission. Official mission data includes the radio observations, but they're described only as anomalous electromagnetic readings requiring further analysis. No public interpretation has been offered. Researchers who obtained the data through official channels have analyzed it extensively. The signal structure shows remarkable similarities to communication protocols used in deep space data transmission, error correction codes, timing markers, and what appears to be a repeated sequence that might represent a message header or identifier. If this was a human signal, we'd recognize it immediately as artificial, Dr. Chen stated. The structure is too complex for natural processes, but we don't know how to decode it because we don't know the encoding scheme. It's like finding a message written in an unknown language using an unknown alphabet. Some researchers interpret the signal as a warning, a notification that Cassini's presence had been detected and was not welcome. Others see it as an attempt at communication, perhaps a response to the electromagnetic radiation Cassini emitted during its observations. A few suggest something more ominous, that the signal represents activation of dormant systems triggered by Cassini's intrusion. If Titan's ocean contains defensive mechanisms designed to protect whatever exists there, the spacecraft's close approach might have awakened protocols that had lain dormant for millions of years. Since Cassini's mission ended, Earth-based radio telescopes have occasionally monitored Titan. Most observations detect only natural radio emissions from Saturn's magnetosphere. But in March 2023, and again in November 2024, brief radio signals similar to the one Cassini detected were observed by multiple facilities. These post-Cassini signals suggest that whatever emitted the original transmission remains active. And the fact that it continues to emit radio signals detectable from Earth raises a disturbing possibility. Perhaps the signals aren't intended for Cassini at all. Perhaps they're intended for us, notifications that Titan systems are operational and monitoring our increasing interest in exploring Saturn's moon. Titan drifts in its orbit around Saturn, wrapped in clouds of methane and nitrogen, its surface temperature cold enough to freeze solid every element of our existence. Yet beneath that frozen exterior lies an ocean larger than all of Earth's seas, maintained by processes we don't understand, containing chemistry that mirrors life's building blocks, and perhaps harboring the solar system's greatest secret. The evidence compiled by Cassini over 13 years of observations points to a conclusion that seems impossible, yet fits the data better than any alternative. Titan's ocean is not a natural accident, but an engineered environment. The chemical stability is too perfect. The thermal hotspots are too organized. The geometric structures are too regular. And the 24-hour operational cycle that references Earth's rotation suggests awareness of our planet from Saturn's distant orbit. If this interpretation is correct, then Titan represents something unprecedented in human experience, a functioning technological installation older than complex life on Earth, built by intelligence that achieved capabilities we're still striving toward, operating according to protocols established millions or billions of years ago. The purpose of these systems remains unknown. Are they maintaining an environment for native Titan life? Were they designed as a seed bank to preserve or incubate organisms? Do they serve as a monitoring station, observing the inner solar system and Earth's development? Or do they fulfill some purpose we haven't imagined because our own technology and understanding remain too primitive? The Dragonfly mission launching in 2028 will provide new data, but it won't answer the fundamental questions about what exists beneath the ice. For that, we'll need more ambitious missions that can penetrate the frozen crust and explore the ocean directly, missions that can examine the geometric structures and sample the chemistry in situ, missions that might finally confirm whether we're looking at natural processes we don't understand or artificial systems we can barely comprehend. Until then, Titan keeps its secrets. The ocean continues its mysterious cycles. The thermal hotspots maintain their impossible heat. And somewhere in the darkness beneath miles of ice, in waters that should have frozen solid eons ago, something remains active. Something that might be alive. Something that built structures to last beyond the lifetime of civilizations. Something that might be waiting. The discovery that changes everything isn't just that Titan has an ocean. It's what that ocean reveals about the true history of intelligence in our solar system and the possibility that we are not, and perhaps never have been, alone in our cosmic neighborhood. We've been looking for signs of alien intelligence in distant star systems, searching the galaxy with radio telescopes and sending probes to the nearest stars. But the most compelling evidence might have been orbiting Saturn all along, waiting for us to develop the technology to see it, waiting for us to understand what we were looking at, waiting, perhaps, for us to be ready for the truth. Titan's secret ocean isn't just about water beneath ice. It's about what that water represents, an environment maintained with purpose, organized with intent, sustained with technology, that operates across timescales that dwarf human civilization. It's about the possibility that the solar system we think we know contains structures and systems older than we imagined, built for purposes we're only beginning to glimpse. And it's about the question that now haunts every researcher who has seen the data. If Titan's ocean was engineered millions of years ago, who built it? Where are they now? And what will happen when we finally venture beneath the ice and discover what they left behind? The answers are waiting, in the dark, in the cold, in the impossible ocean that should not exist, but does. Titan holds its secret still, but perhaps not for much longer. The data suggests we're looking at something extraordinary. The evidence points to intelligence operating on timescales we can barely conceive, and the implications challenge everything we thought we knew about our place in the universe. The discovery that changes everything is this: we may be late arrivals to a solar system that has been occupied for far longer than we ever suspected, and on Titan, beneath a frozen crust on a moon circling a distant giant planet, the evidence of that ancient occupation continues to function, continues to operate, continues to wait.